Hi, welcome back. This is Professor Ridge, and today's lesson 6.7 is on synthetic division. So how do you divide without really dividing? Okay, so first let's consider this long division problem. If I take 3x squared divided by x, that's going to get me 3x. Multiply, that's 3x squared plus 9x. I'm going to subtract, so that'll get me minus 7x. Bring down the next term. And then I go negative 7x divided by x is negative 7. Multiply. And then I'm going to subtract, so that'll give me plus 26. And what happens is with synthetic division, you're going to take whatever you're going to change the sign. You're going to use negative 3, and you're going to write negative 3 over here, and then you're going to take your coefficients 3, 2, 5. And what we do is we're going to bring the first term down, and then you're going to multiply the negative 3 times the 3 and write your answer there. So again, bring the first term down, then negative 3 times 3 is negative 9. And then you're going to add down, so 2 plus 9, negative 9 is negative 7, and then you're going to multiply, so now I'm going to multiply, and write the answer up here, which is 21, and then you're going to add down the column, 26. And notice, look at my answer over here. I got the 3, see, 3x minus 7, and then the remainder. Okay, so if this is x squared and you're dividing by x plus 3, this is going to be 1 degree less than what you started, so that's going to be x. That's going to be your constant. And then that's going to be your remainder. So that's the process. You bring the first term down, you multiply by what's in here, and then you add put the result into the next column, add down the column, multiply, add down the column, you just keep going until you're done. Alright, let's try a couple of these. Okay, so again, you're going to change the sign. We're going to change sign. So we're going to put 3 right there. And then you're going to put in your coefficients. In descending order. And put in any missing zeros for any missing terms. So it's 1x cubed minus 4x squared plus 5x minus 6. Bring your first term down, and then you multiply by everything in the bottom row by that 3. And you go 3 times 1 is 3, and then you add down the column. Negative 4 plus 3 is negative 1. And then I multiply negative 3, add down the column, and then I multiply. So that's 6, and then I add down the column. So remember, this is x cubed, so this one will be 1 less, 1 degree less. So it's x squared. So we go x squared, 1x squared minus 1x plus 2 with no remainder. That's your result. See, pretty simple. Let's try another one. A squared plus 8a plus 11 divided by a plus 5. So we're going to go 1, 8, 11. I'm going to change the sign, make that negative 5. Bring the first term down, and now multiply everything on the bottom row by the negative 5. So negative 5 times 1, negative 5. Add down the column, 3. Negative 5 times 3 is negative 15. Add down the column, it's negative 4. So our result is going to be, so this was a squared, so this is going to be a plus 3, and then that's your remainder over the divisor. And there's your answer. Now let me try another one. X cubed minus 10x squared minus 9x plus 15 divided by x minus 4. So again, we're going to bring the coefficients, 3, negative 10, negative 9, 15. Then here we're going to change the sign. So that's going to go, and don't forget to change. So that'll be positive 4. Bring the first term down. 4 times 3 is 12. Add down the column. Negative 10 plus 12. 4 times 2 is 8. Negative 9 plus 8 is negative 1. Negative 4, so your remainder is 11. So you're going to go, this is 3x cubed, so we're going to go down 1 degree and get 3x squared plus 2x minus 1 plus a remainder over x minus 4. And as simple as that. Number 16. So remember, you got to put in descending order, and if there's missing terms, put in 0. So it's going to be 2 minus 3, that's x squared. There's no x, so you put a 0 for there, plus 8. Then you're going to divide by x plus 2, so you change the sign, make that a minus 2. Bring down the first term. Negative 2 times 2 is negative 4. Add down the columns. Negative 14. Add down the columns. So that'd be plus 28. Wait a minute, this would be positive 14. Negative 2 times negative 7 is positive 14. So I was right when I had the negative 28 there, but not because I did it right. So 8 plus negative 28, that's negative 20. So then my solution, so remember this is x cubed, x squared, x constant, and then down here it'll be x squared, x constant remainder. And I don't, and normally I don't write that, of course, but just showing you. So the remainder you put over the divisor. And there you go. Okay, so now the next thing, there's what's called the remainder theorem. So let me write that down for you. So it's pretty simple. The remainder theorem just says that if you take a polynomial, p of x, and divide it by x minus r, the remainder is going to give you the same number as if you plugged in r into that original polynomial. So if we look at, for instance, if I said p of x is 2x cubed minus 3x squared plus 8, and I asked you to put in negative 2, so see this is minus r, this is r, so those signs are different. So if I put in negative 2 into here, plug it in, I should get the same thing as the remainder. P of 2 is equal to the remainder of doing p of x divided by x minus minus 2, which would be x plus 2. P of negative 2, I'm sorry. Okay, so I'm saying that this should be equal to negative 20. Let's see if that works. Negative 2 cubed is negative 8. Negative 2 squared is 4. So we get negative 16 minus 12 plus 8, which in fact is negative 20. So that's not coincidence. That's actually this theorem. It's saying that if I plug in the opposite of that, negative 2, into the function, negative 2 into the function, it will give me the same value as the remainder. Okay? So this gives an alternate way to figure out function values, which before the day of calculators, the days of calculators, this was actually pretty useful. So if I want to use the remainder theorem to calculate, okay, so remember that you got to put it in descending order. 3x to the fourth, 0x cubed, 25x squared, 0x minus 18. And this sign's already changed, so you just put 3 here, not negative 3. If that said x minus 3, you change it to 3 to put in here, or change it to 3 to put in here. But this number 3 and this g of 3, the 3 has already been changed, so you wouldn't change it again. Okay, so it's already changed. So bring down the first one, 9, add down, so that's negative 2, no, positive 2, 6, add down, and you get 0. So g of 3 is equal to 0. And if you want to check, g of 3 is equal to 3 to the fourth minus 25, 3 squared minus 18. So that's 81 times 3, 25 times 9, it's 243, 225, and I hope that's 0. Yeah, it is. Okay. So you could calculate it either way. You can plug it in, or you could do it using synthetic division. So it's a nice little trick. All right, let me do one more. 26. Okay, so I want to find p of 2 using synthetic division. So 1x to the fourth, 7x cubed, 11x squared, minus 7x, minus 12. So again, we just write the coefficients. This number's already been changed. Bring down the first one, multiply. 1 times 2 is 2, add down, 7 plus 2 is 9. Multiply, 9 times 2 is 18, add down, 58, add down, 102, add down. So P of 2 is equal to 90, which is the remainder. That's the remainder theorem. Again, you can check if you want and plug in 2 into the function for all the x's. So that's 16 plus 56 plus 44 minus 14 minus 12, which is, I hope, 90. I'll let you check that. I'll do it. 62, 100. Yeah, it works. Alright, so that completes your lesson for 6.7, and I'll go to MyMathLab, complete all your exercises there, and I'll see you next time.